Okay, how did you make out solving your first system of linear equations in 3 variables? That's problem number 14. Well, your hint was divide the top equation by -3, or at least I suggested that to you. Notice you could go lots of different ways in solving these problems. This is only the path that I happen to do today. You could have done this a very different looking way with equivalent steps and done it correctly. Anyway, I divide that top equation by -3 to make it look like that, and I combine it with the third equation. Reason being, I've arranged it now so that I have x and -x. So when I add up these two equations, the x terms disappear. So I've eliminated one variable. And I get -y, and then something funny happens. This is kind of a lucky break. The z's also cancel out. Sometimes that happens, usually not. So I end up with y equals 4, and this saves me a bit of work. I immediately know what one of the variables is. So I go pick a different equation. I just used 1 and 3, so now I'll pick equation 2, and I'll plug y equals 4 in it right there. Solve for x and z. Simplify it, and I get this. I end up with an equation in 2 variables, x and z. So if I can combine find another combination of equations and get rid of the x again, then I'll end up with another equation in x and z, and I'll have 2 equations in the same variables, which is the problem we learned how to do 3 weeks ago. Okay, so let me take the third equation and I'll plug in y equals 4. Once again, I'm left with x and z. Here's my equation. So now I take that equation, put it there, this equation, put it there, and I've got the problem that we were doing 3-4 weeks ago. 2 linear equations and 2 variables. If I multiply the lower equation by -1, I can arrive here so that when I add, I get -z equals -1, and the x's are gone. And I have now figured out what z is. So at this point, I've got the problem pretty well under control. Pick one of the equations I haven't just worked with, like the first equation, plug in the value for y, plug in the value for z, and solve. I get x equals 14. That's kind of a big number. It's kind of funny. Let's check and make sure it's right. Well, I just used the first equation. Let me just use the second equation. I'll take that second equation and plug in. I get 6. Okay, so it checks. So my answer can be represented like this. 14, 4, 1. X is 14, y is 4, z is 1. This is an ordered triple. You know, all semester we've been graphing points in the plane that were ordered pairs. But you can keep adding dimensions on, and now we have 3 dimensions, x, y, z, and we have an ordered triple. And you could go on and on and on. The next one would be an ordered quartuple if you had 4 of these variables. Then ordered quintuple if you had 5. And in fact, there's even a name if you went to just n. For any number n, it's called an n-tuple. So, that makes you all experts in this, right? For your homework, to show off your expertise, on page 518, just 2 problems, 9 and 13. This is not a problem that we're going to emphasize a whole lot, so you only have 2 problems to do. Now, I have the feeling that our next topic, though, will be emphasized, and we might see one of these problems on the final exam. We're going to skip 7.1, 7.2, 7.3, 7.4, and 7.5. Those chapters, those sections were on matrices, and that is an optional topic that was in our original syllabus before we missed a week of classes. So I'm knocking matrices out of the course, and you can certainly go on to calculus and higher math without this matrices background. But 7-6 is pretty useful. You're going to need to know how to do that. Up till now, we've solved systems only with linear equations, but there's no reason why you couldn't use the same techniques with nonlinear equations. We'll keep it simple and we'll go back to two variables. So look at example 1. X squared minus x minus 3y equals 0. That's the first equation. Clearly, it's not linear. There's an x squared in there. Down here, the other equation is x minus y equals negative 4. Okay, that's a linear equation. Usually, the easier way to go with these nonlinear equations is just use substitution. Although elimination works sometimes pretty conveniently. Whatever you think is going to work better in any particular problem. So I'm going to take the bottom equation because that's nice and simple, and I'll just solve for y. So I do those steps, and I figure out that y equals x plus 4. Go back to the first equation, right, this one here, and replace y with x plus 4. So I have this. Simplify, right? We're always simplifying. You see why there are so many simplification problems at the start of the semester? You can't do much else as you go on in math without being able to simplify. I get down here and you say, oh, quadratic equation, let's try to factor it. Fortunately, this one factors. If it didn't, we'd have to use the quadratic formula. But we get these nice integer solutions. X equals 6 or x equals minus 2. So then you say, so, I'm going to figure out a y value for each one of these x values. That's like getting two ordered pairs. Do we have two solutions? Well, think about it. This is a parabola, right? We could isolate y, and you would see a parabola that opens upwards. I don't know what it looks like, but here's a parabola that opens upwards. This line here, yeah, this is y equals x plus 4, so it goes through 45-degree angle. See, oh yeah, so a line can hit a parabola in two places. But if the parabola shifted up, the line would miss it, so a line could miss a parabola entirely too. Or the line could go by and just touch in one point. Right, so you can either have no solutions, one solution, or two solutions. In this case, you see we have two solutions. So, I think that this combination, x equals 6, y equals 10, I think that that's a solution. Now we can go and check right here. I'll pick the first equation because I just used the second equation here. So I pick the other equation, 6 squared minus 6 minus 3 times 10. All right, that's x, 6 replacing x, and then 10 replacing y. This gives me 36 minus 6 minus 30, which gives me 30 minus 30. Okay, so it turns out to be 0, which is what I needed it to be. So that combination works out. Now, what should y be when x is negative 2? Again, plug into the other equation here. I get negative 2 squared minus negative 2 minus 3 times y equals 0. Oh, well, I guess I could have plugged it in here too. But either way, 4 plus 4 minus 3y equals 0, so I've got some kind of boo-boo here. Let me go back to my notes. I'll just use the simple equation. X minus y equals negative 4, so negative 2 minus y equals negative 4. So I get minus y equals minus 2, therefore y equals 2. And let's go ahead and check this. Now I have to use the other equation. So I have minus 2 squared minus a negative 2 minus 3 times y, but I am claiming that y should be 2. So this should all work out to be 0 again, right, in that first equation. So I'm going to get 4 plus 4 minus 6, oops, 4 plus 2 minus 6, which equals 6 minus 6, which equals 0, so that one works out in there also. So I have checked my answers and I've got the problem solved. For your answer, you can write down x equals 6 and y equals 2 and y equals 10, and then when x equals negative 2, y is positive 2, or you may choose to write your answer with ordered pairs. You could say solution, here's another one of our popular abbreviations, SOL for solution. The ordered pair 6, 10, right? X equals 6, y equals 10. And then the ordered pair negative 2, positive 2. And that's how you would solve one of those examples. How about graphically? Let's look at example 4. Example 4. We've got this system. Y equals negative x squared minus 2x plus 8. You say, ooh, that's not linear, it's quadratic. So the graph is a parabola. Furthermore, it's a parabola that opens downward with y-intercept equals 8, right? And if you put that into your graphing calculator or into the Desmos program out there on the internet, you get a picture that looks like that. There's that parabola. The other equation in my system is linear. To get it to graph in the calculator or the computer, let's solve for y. So it looks like that. So this was 8. This y-intercept is at 4. And slope is negative 2. So we get something like that. And you see 2 points of intersection. Now, use your device to zero in on those points of intersection and you will get your answer. Right? The points of intersection are the solution. So in this case, the devices tell us negative 2 and positive 8 and 2, 0. So actually this should have occurred on the x-axis. I didn't draw it perfectly accurately. And this is figure 7.27 in your textbook on page 575. So that's how you can use the calculator or the computer program to solve your problem. Now, do number 8 in your homework. That's on page 577 Number 8. Let's work that one out.